Hello everyone. So in the last video we talked about indefinite integrals and the difference between definite integrals and indefinite integrals. And now that we've understood how to solve for antiderivatives of various functions, we can actually solve definite integrals by hand now. And I know I said it's scary up here. Really, it's not that scary, okay? Don't be afraid of doing stuff without a calculator. Yeah, you may be prone to a little bit more math mistakes, but with the more practice you get, the less of those mistakes you make. Um, so we had previously been solving definite integrals. We had a couple ways to do them. We first introduced doing Riemann sums and trapezoidal sums, but that gave an approximation. It wasn't accurate. Next, we viewed these definite integrals as areas under a curve. But then we were still limited to either specifically being given the area to determine what the definite integral was, or we needed some kind of geometric shape that could be easily calculated that we could use to find the exact area under the curve. So therefore, if our curve did not look like a rectangle, a triangle, or a trapezoid, we were kind of out of luck there. And so then we learned how to solve these definite integrals, but we use the f and I and t function in our calculator. So now we're going to go to the last step. Now that we know what antiderivatives are, we know the antiderivatives of various functions, we can actually go through and evaluate those antiderivatives to determine what that net change is. Okay? So notice that when we have this, we have no plus c's that come out of here. Why don't we have a plus c? Well, because when we evaluate an indefinite integral, in one case, we would have had a plus c here. And then when we subtract the next one, we would have had another plus c here. If we have plus c minus plus c, that just goes to 0. So when you have definite integrals, you don't need to include those c values because no matter what, when you do this subtraction right here, these are going to go away. Now, just so you know, there's another kind of notation for f of b minus f of a, which I'm going to be using a lot, and it looks like this. We look at the antiderivative and we put the limits of integration in a straight line like that. That means do f of b minus f of a. But just so you know, it's written that way sometimes. I just want to make sure that you guys don't freak out when you see that symbol because it just means f of b minus f of a. All right, so let's look at an example problem doing this. So what I want you guys to do is I want you to evaluate this definite integral by hand. Now I know that might take you a while. Please resist the urges to just go straight to your calculator and do this. Come up with a number. You can double check it using f and I and t in your calculator, but really just give this a shot because this is very important to know how to do this, in particular for the non-calculator versions of the AP exam. Now, I doubt you're going to have to evaluate a definite integral this difficult by hand, but you know what I like to do, if I give you something harder than you're ever going to encounter, that means the other stuff should seem relatively easy. All right? So give this one a shot, pause the video. Okay, so if you did this, the first thing we got to do is evaluate the antiderivative. And again, I'm going to use that kind of shorthand notation I showed you on the previous slide. So the antiderivative of this will end up being negative 2/3 cosine 3x minus pi over 6 minus 1/2 sine of 2x from 0, that's a bad vertical line, from 0 to pi over 6. So again, if you didn't get to this point, go back, stop the video. Because we had so much explanation in the previous videos, I'm not really going to go over this one too much. Go back to the previous video that we just had when we looked at that one variation of having a function within a function in an integral where we could kind of apply the chain rule backwards. That's what we're doing here. This is basically a linear function right here. So I just multiply the antiderivative of 2 sine of this thing by just 1/3 out in front. That's why we get negative 2/3. The negative comes from sine, or the antiderivative of sine is negative cosine. So anyway, again, if you're stuck on that part, just come see me during tutorial or something like that, and we can go over this. But for right now comes the kind of crappy part. We just got to plug and chug this stuff through, all right? So if you didn't get to this part, if you didn't get the antiderivative right, pause the video again and now try to evaluate what this will be. All right, so if you gave this a shot, the first thing we got to do is find out essentially remember, this is our antiderivative function f of x, okay? So the first thing we got to find is capital F of b, or in this case, capital F of pi over 6. So that will be negative 2/3 cosine of 3 times pi over 6 minus pi over 6 minus 1/2 sine of 2 times pi over 6. So we have that, and look what I'm going to do right here. Notice the big parenthesis I put out here. I'm going to put another one here. Whenever you do your capital F of b minus capital F of a, get in the habit of always putting parentheses around these terms. Why is this the case? Remember back when we did like difference quotient problems a while ago, and in that case we had f of x plus h minus f of x to calculate a derivative in the numerator of that limit. I said before your minus f of x, that right side, you always want to put a parentheses over there. The reason why is because when you have functions that are like this, that have multiple terms in them, if you don't put that parentheses there to the right of that minus sign, you could screw up and not distribute that minus sign properly. So putting the parentheses is a check that we use to distribute that minus sign. So we will have minus parentheses negative 2/3 cosine of 0 3 times 0 minus pi over 6 minus 1/2 sine of 2 times 0. Close it all off, and there we go. Notice again that because I put these parentheses right here, it reminds me to distribute that minus sign. So that means both of these things become positive. Now, if you forgot to do that, it could have been really easy. Now, in this case, it doesn't matter because sine of 0 is just 0. But let's say that was, a non-zero term. If you forget to distribute that negative sign and you include this little negative sign and you don't flip it to positive, you're going to have major problems and you're not going to be getting the right answer. So again, be very liberal with your use of parentheses. Okay. So if you guys want some practice with trig functions, keep on going at this without a calculator. If you do that, you should eventually wind up at the answer. This will give you square root of 3 minus 4 over 12 is the final answer you get. Now, you might get that in a different form than I did. That's fine. But what I'd encourage you to do is solve this definite integral above up to the point where we're doing it right here and we're just plugging in numbers, and make sure you can plug in those numbers and wind up with an answer that is equivalent to this one right here. Now, preferably, it's good if you can get down to that answer or something that's similar. It doesn't necessarily have to be in the most simple form, but it's good if you can work it down all the way from that. And again, this is probably more complicated than anything you would get in a multiple choice problem. So if you can do this, you should feel pretty confident. So let's do one more example. All right, give this function a shot. Pause the video. Okay, so if you tried this one, again, I'm going to use that shorthand notation. Well, the derivative of e to the 3t, or the antiderivative, will be 1/3 e to the 3t. And then here, this, remember, that's going to be related to the natural log function, and we have that linear function inside of it. So this will end up being minus 1/2 the natural log of the absolute value of 2t plus 1. And here I'm going to use that shorthand notation again from 0 to 2. So if you weren't able to get right here, pause the video, see what problem you were having evaluating the antiderivative and try it again. If you were able to get to this point, keep going and try to actually find what number we get when we attempt to solve this. Okay? So when we go through this, again, we're going to want to apply our two limits of integration. So first we'll have 1/3 e to the 3 times 2 minus 1/2 the log of 2 times 2 plus 1. Notice I ditched the absolute value because this is a positive number, so I don't need an absolute value anymore. Just don't need that cluttering everything up. Put the parentheses around it. Then remember we will have minus 1/3. Put the parentheses around the big one. E to the 3 times 0 minus 1/2 the natural log of 2 times 0 plus 1. Again, this is positive, so I don't need the absolute value. So you should end up with something like this. Now, I'm drawing this stuff in super big, font on the smartboard. You guys aren't going to need these ... ellipses. I'm just doing that because there's no way I could fit all this stuff into one line. So if you guys are working on your paper, go ahead, fit the stuff into one line, go nuts, okay? So if you go through with this solution, you'll end up with e to the 6 over 3 minus natural log of 5 over 2 minus 1/3 should be your final answer. Again, this is my answer I got without using a calculator. See what answer you got. Again, it's important that you can whittle it down to something that ends up being equivalent to this. Preferable if you can do this the whole way without a calculator. But again, a definite integral like this is harder than anything you would experience on the multiple choice section of the AP exam. I know I sound like a broken record now, but I just want you guys to know that so you're not freaking out. Again, I'm giving you kind of the hardest type of examples you can expect to get, and if you guys can do those, you should be very well prepared for anything that's easier. So again, look to the book for more example problems if you want to find some, or ask me for some in class. Other than that, we have one more section in this unit, and that video is going to be based on solving what are called initial value problems.